Hello everyone. We'll start rotational motion today. Write down rotational motion. When we were discussing circular motion, we are mostly interested in the centripetal force. We discussed little bit the tangential part also, but mostly that was centripetal because most of the time we were interested in uniform circular motion. And in uniform circular motion, you know that only centripetal is something which is required. And the other thing, in circular motion, we discussed only the point mass. In this rotational motion, we will discuss circular motion of several points. That means rotational motion of a rigid body. For example, if I rotate this marker, there are several points on this marker which are rotating in different circles of different radii. If you look at any individual one, then it is basically what? Circular motion. But if you look at the whole body, the whole marker, then it comes in this rotational motion of rigid bodies. But fundamentally, every point on the body is doing what? Circular motion. And the important part in rotational motion is tangential force. In circular motion, we are interested in what? Centripetal. In rotational, we are interested in the tangential part. Let's understand the whole thing with the help of this thing. Write down torque. First look at this figure, or just tell me a few things. Suppose this is a rigid body and I just want to rotate this rigid body. If I want to rotate this rigid body, then I need to apply a force. So the first thing which I can ask you is, if force is acting on a body, then is it necessary that body is going to rotate? Let me repeat my question again. If I apply a force on this marker, then should it rotate always? What do you think? Yes or no? If a force is acting on a body, तो जो क्वेश्चन मैंने पूछा है वो ये, क्या उस बॉडी को रोटेट करना पड़ेगा? Yes or no? Some of you are saying yes, but many are saying no. In fact, good. Nobody is saying yes. I thought that one of the remark is yes, but right now it seems that nobody is saying yes. Good. That's the correct answer. Now let me prove this. This is the marker. If I apply a force on this marker over here, a force is coming from my hand this way. You can see that the marker is rotating because of the force. So it seems that if force is acting on the body, then it must rotate. But look at this place where I am holding the marker. Right here. This place is called axis of rotation. This marker is going to rotate about this position. There is an axis, and about this axis this marker is going to rotate. If I apply a force on the body at the axis itself, then you can try yourself, this marker is not going to rotate. And everybody, हर आदमी ने इस चीज को फील किया होगा कि जैसे जैसे आप फोर्स एक्सिस से दूर लगाओगे आपके लिए बॉडी को रोटेट करना क्या हो जाएगा, इजी. इसीलिए जो गेट होता है उसका हैंडल कहाँ लगता है, एक्सिस से जितना डिस्टेंस हो उतने डिस्टेंस पर, जितना ज्यादा डिस्टेंस आप मेंटेन कर पाए. You will never find that if this is the hinge about which gate can move, rotate, turn, then you'll find that the handle part is over here. If this is a gate, and you can rotate the gate like this, then you will find that handle appears over here. This is the axis about which gate rotates, the position of hinge. So which tells us what? If force is acting on a body, and that force is acting on the body at the location of axis of rotation, then this body can never rotate. Write down this first statement. If a force acts on a body, if a force acts on a body at the location of axis of rotation, then this body will not rotate. Now let me ask you the second part. If I say that force is acting over here at the maximum distance from the axis, maximum possible distance from the axis over here. So if somebody says that force is acting over here, then is it necessary that this marker should rotate? What do you think? Yes or no? If I tell you that force is acting right here, then this marker in that condition, should it rotate? What do you think? Yes or no? Well, now everybody is saying yes, but answer is again no. It's not necessary that this marker should rotate. Remember, I just gave you what? That force is acting over here. I did not give you the direction part. Hold the marker or any body, and if you apply a force on the body in the pulling sense, as if you are pulling the whole body. So if I apply a force is coming from my hand in this direction, remember. I'm trying to pull this marker. As I pull, this is the axis. This hand represents axis of rotation. That's how it can rotate. But if I try to pull this marker like this, then you can see that it doesn't rotate. But if I apply force like this, then it starts rotating about this axis. So we have found these few things. If you want to rotate something, then you need force. But force alone cannot rotate a body. If I apply force over here, it will. If I apply force over here, then it doesn't. And therefore, you need to provide position of point of application of force. In simple words, जहां पर फोर्स लगा रहे हो इस जगह की पोजीशन एक्सिस के अबाउट आपको बतानी होगी. Position is given with the help of R for position. So you have to have what? Force, but force alone cannot rotate a body. You need to provide position. If R is 0, R means this distance. If R is 0, then this marker is not going to rotate. Then I told you that if somebody applies force over here, then even then it's not necessary that this marker should rotate. It also depends upon the direction. If force is acting like this, then this marker doesn't rotate. If force acts like this, then the marker rotates. That means apart from force, position, we also need direction. Direction is given by theta. If we have information of these three, then only we can decide that a body can rotate or not. This information, which is present in the form of F r theta, collectively is called torque and is given by this symbol, which is called tau. So torque, this is T with a curve called tau. Torque. What is torque? Combined effect of F, R and theta. This was the base introduction, the way body rotates. You will understand everything with the help of this figure. Look here. This is representation for axis of rotation. This is the axis of rotation. Axis is what? Is a line. So this is the line. Right here, you get the position. Position. Position is given by what? R vector. On the body, at this point, we have a force which is acting in this direction. This is the force. What is this representation? Remember, this is for axis of rotation. This R, it gives you what? Position. We can call it position vector. And F, everybody knows is what? Force. क्या सेटअप बना हुआ है यहां पर? Look at this marker. This is the This blue marker, if you can see, if you cannot, no issue. This marker represents axis of rotation. So the black marker is going to rotate like this. This is the axis, this is the rotation about the axis. Right here, we have a force acting on the marker. So this force is shown with this arrow. R, position vector, axis of rotation, direction of force. The first thing, just tell me, what is the angle between this force and position vector? It's an acute angle or it's an obtuse angle? Just give me an idea of this theta. What do you think in this figure? Angle between R vector and F vector, is it acute or it's an obtuse angle? Good. कई लोगों को लगता है कि भाई ये एंगल चल रहा है, and they simply answer that the angle between F and R is this. But remember, and if you do not know, then you can write the statement also. When we find angle between the vectors, we always join them with their tails. What did I say? If somebody needs angle between this vector and this vector, then the approach is what? Join both vectors with their tails like this. This is F. Draw the F vector. Draw the R vector. And this is what is theta. In reality, R vector starts from here, force is acting at the tip, but if somebody asks you find out the angle, then always do this. So those of you who are interested can write the statement, write down the statement. As a special note, you can make a side note. For finding angle between two vectors, their tails should be joined together. For finding angle between the vectors, their tails should be joined together. Now, once I say this is the angle theta, this theta in this setup is this one. This is F, this is R. In the real setup, this is F. We have found that this angle is theta. Force is acting over here. Produce this line. This angle is theta. Simple geometry. क्यों किया हमने ऐसा? अब वहां चलते हैं. बोर्ड पर देखना केयरफुली. जब भी अपने को कोई वेक्टर थीटा टाइप के एंगल पर लगता दिखता है तो सबसे पहली चीज अपन क्या करते हैं? We try to resolve this thing. So let's do the same. This is F, this is theta. This component is F cos theta. I hope you can see this thing. This is F cos theta. This is F cos, then this component is F sin theta. This is written F sine theta and this is F cos theta. Now tell me, which component can produce rotation in the body? F cos or F sine? Write down this in the comment box. Draw this much information. Answer this. Which component can rotate this body? Cos or sine? And it is something which everybody can feel. And yes, your feeling is good. Your answer is correct. Rotation is possible because of F sine theta. You cannot produce rotation because of F cos. क्यों? थोड़ी देर पहले बताया था कि अगर मैं इस मार्कर को इस तरफ फोर्स लगाऊंगा 90 पर, then this marker is going to rotate. But if I pull this marker along the length, then assuming rigid axis, this thing is not going to rotate. If you apply excessive force, then the whole thing will move in this direction, but there is no rotation. For rotation, you need to have what? F sine theta. This component. Which component? Component which is perpendicular to R vector. Write down the statement. For rotating the body, entire force F is not useful. Its F cos theta component, does not participate in rotation. Rotation is possible only because of F sine theta component. Rotation is possible because of F sine theta component. Now, the term torque is this. We have found that entire force F is not responsible. You apply a force at a distance of what? R. How much force? Not F, but F sine theta. This combination of R, F sine theta collectively is called what? Torque. So if a body is going to rotate or not will be decided by this number. If torque is coming 0, if somebody applies force over here, कहाँ पर? Axis पर, इसका मतलब R क्या हो जाएगा? 0. If R is 0, torque will become what? 0. हमने देखा था अगर एक्सिस पर फोर्स लगाएंगे तो रोटेट नहीं करेगा. If F is 0, अगर फोर्स ही नहीं है तो फिर बॉडी रोटेट करेगी ही नहीं. R भी है, F भी है, but if somebody applies force like this, in this direction, if entire force is in this direction, that means what is theta? If force is in this direction, that means it's parallel to R. Theta is what? 0. What is sine 0? 0. So this product RF sine theta, which is called torque, decides whether a body is going to rotate or not. Write down this much, and if you understand the whole thing, then write down yes in the comment box. Now आप एक अलग फिगर में इस चीज को ड्रॉ करना, मैं यहां पर दिखा रहा हूं. We can remember this RF sin theta in this form. You can draw a separate figure. Remember, this is position, this is your axis of rotation. Look at this. This angle is theta. If you produce this line of force backwards like this, what is this? This is called line of force. कोई स्पेशल चीज नहीं, जिस डायरेक्शन में फोर्स लग रहा है हमने इसको बोल दिया है लाइन ऑफ फोर्स. What is this? The point where force is acting. This is point of application of force. You can also write like this. If force is acting over here, this is the point of application. If force is acting over here, this is another point of application. Force is acting over here, this is the point of application. So this is point of application of force, and its position with respect to axis of rotation is what? R. What is this? Line of force. Why do we choose these different terms? There are infinite number of forces which can act at a given point of application. You can apply a force like this. You can also apply a force like this. You can apply a force like this. So if a force is acting over here like this, they have same point of application but they have different directions, which means different lines of force. Not a difficult task, समझ में आ गया होगा. The point is, if this is theta, this angle is also what? Theta. Now who will tell me what is this distance? Write down in the comment box, what is this distance? This is the perpendicular distance. This thing has a name. What is the name? This is your axis. This is your line of force. Look at this perpendicular distance. So we'll get me the value of this blue line, which is called perpendicular distance of line of force from the axis of rotation. But note करेंगे, but let me see how many of you can give me the value of this blue line. Only one person has answered, and this answer is correct. Look at the right angle triangle. What is this? R. This is perpendicular. So what is perpendicular component? Perpendicular component is what? R sine theta. R sin theta. Hopefully दिख रहा होगा. Change the color. I'm using blue so that you can easily identify. This is r. This length is what r sin theta. क्यों हम इस r sin theta के पास गए? जरा यहाँ देखना. ये जो टॉर्क लिखा हुआ है, हमने इस टॉर्क को इस तरह से अरेंज किया. F multiplied by r sin theta. We have grouped r with sin theta term. फायदा क्या हुआ? Now we can make a statement. What is torque? Force multiplied by r sin theta. What is r sin theta? R sin theta is perpendicular distance of line of force from the axis of rotation. Look at this. This marker is the axis. This is line of force. This least distance between these two is called perpendicular distance, which is r sin theta. Draw this, note down this, and then we'll write a statement. Write down the statement. Torque is force multiplied by perpendicular distance of line of force from the axis of rotation. Torque is force multiplied by perpendicular distance of line of force from the axis of rotation. This way, if you remember it, it's a useful version. इस पर ज़्यादा दिमाग लगाना है. We'll solve a few questions, तो आपकी प्रैक्टिस भी हो जाएगी. लेकिन अब अगली चीज पर चलते हैं. But let me ask you first, what type of quantity torque is? Is it a scalar or it's a vector? Write down in the comment box. What is torque? A scalar or a vector? Let me see if we have some idea of this. That's the more correct answer, but we do not answer this thing in school. perfectly correct thing is it's a vector. More correct thing is pseudo vector. It's not a vector, it's an artificial thing. You can, the artificial thing, like just if you remember circular motion, the concept of angular displacement, angular velocity, angular acceleration, all these things were what? They were vectors. लेकिन हमने उनको अपने लिए, अपने पर्पस के लिए वेक्टर्स की तरह से इंट्रोड्यूस किया था. This or this, same is torque. So torque is a vector. Schools, competitive examination, हर जगह आपने टॉर्क को क्या बोलना है? वेक्टर. बट ये दिमाग में रखना, the pseudo vector. Pseudo means not that kind of pseudo, not that kind of pseudo. It's an artificial vector. Forcefully आपने इसे क्या किया हुआ है? वेक्टर की तरह से इंट्रोड्यूस किया है. Just forget about it, क्योंकि हमने इस चीज को सर्कुलर मोशन में डिस्कस किया था. कैसे किया था हल्का सा बता दे रहा हूं. First of all, look at this and tell me first, this body which you see on the board, the body which is under the force F is going to rotate clockwise or anti-clockwise. Write down fast. If you think clockwise, write down C. If you think anti-clockwise, write down A. C for clockwise, anti-clockwise, A. Write down fast. What type of rotation do you see? Clock or anti-clock? Good. सामने दिख रहा है. ये है body. यहाँ से आया force. Look at the force. As the force acts, you can see the marker. Look again. The force, it rotates the body in this form. Sense of rotation. This is the direction of torque vector. So what is direction of torque vector? Anti-clockwise. This is torque. And you know that whenever you represent something like this, it's a curve. And vectors are represented with the help of what? Straight arrows. So we have to give it some directional sense. And that directional sense is what? Hold your thumb perpendicular to your palm. Curl, curl, curl along the rotation. Thumb, I hope you can see that thumb lines up with the axis of rotation. So this torque has this direction. What is this direction? This direction is, either you call it clockwise, anti-clockwise, or you can call it dot. Either you call it anti-clockwise or dot or k cap. In normal sense, ये अपना x, ये है y, x, y, आपकी तरफ क्या आता है? Z. What is unit vector for Z? K cap. So this situation is what? If somebody says find out direction of torque, we'll say anti-clock or dot or k cap. Now because of this, it's an artificial vector. कैसे? हमने डिस्कस किया था इस चीज को सर्कुलर मोशन में कि अगर हर आदमी लेफ्टी होता, लेफ्ट हैंड यूज करने वाला, तो फिर if I use the left hand, look at the rotation. It is again anti-clockwise, but the thumb is now pointing in. तो अगर दुनिया का हर आदमी लेफ्टी होता, सिस्टम लेफ्ट के बेस पे डेवलप हो रहा होता, तो हम क्या बोल रहे होते कि जो टॉर्क है इसका डायरेक्शन क्या है? इन. And therefore you may find that at some place or some other place you will find that they say that torque and all angular velocity and all, these are what artificial vectors. लेकिन ये चीज अपने तक रखना, समझा दिया क्यों? स्कूल्स एंड ऑल के लिए टॉर्क क्या है? वेक्टर. किस तरह का वेक्टर? इट हैज अ स्पेशल नेम, टॉर्क. इस चीज को हमने फिर से सर्कुलर मोशन में यूज किया हुआ है. टॉर्क, angular velocity, angular displacement, angular acceleration, these are what? Axial vectors. What is the direction of torque? सामने, anti-clock, or dot, or k cap. Note down this much. And write down the statement. The statement is torque is an axial vector. Torque is an axial vector that is, its direction is along the axis of rotation. That is, its direction is along the axis of rotation and is given by right hand. Curl right hand fingers. Curl right hand fingers in the direction of rotation. Curl right hand fingers in the direction of rotation. Then thumb points in the direction of torque. Now, we'll discuss the direction part when we handle some examples and all. But before that, what is the unit of torque? Write down the unit of torque. Write down the unit of torque fast in the comment box. Very easy. What is the unit? Newton or meter. Newton into meter. But have you seen this Newton into meter before? Have you seen this unit Newton into meter before? If yes, then where? It's not called pseudo. One of you is asking that why it's called pseudo vector. It's not pseudo in that sense. In the sense like pseudo force, it's not a pseudo force type of thing. Pseudo force is something which is for non-inertial observer. You know a lot about that. Pseudo vector means this body is rotating. To explain the concept of rotation, we are using these three things. If you're not interested in torque, you can keep force r theta separate. You can investigate everything in the body. You can describe every part of it. If we do not use f r theta collectively as torque, but that will increase the difficulty level. You will have to use lots of integration and all. To avoid those things, we have combined f r theta in this form, which is called torque. Now once it takes this shape, then we found that bodies, they can rotate either anti-clockwise or they can rotate what clockwise. Only two directions are possible, anti or clock. So anti and clock. Now how do you define vector? If I say that this is the vector, if somebody says this is the vector, then how do you provide direction of this? It makes no sense, because you know that this thing has different directions everywhere. This anti-clockwise motion is in this direction if somebody uses what? Straight arrows, straight arrows, straight arrows, straight arrows. So what we did, we say that if body is rotating anti-clockwise, then hold your thumb out, stretch it like this. This thumb just say gives the direction of what? Torque. Which means now if I tell you that a body has a torque acting on it which is pointing inwards. The moment I say torque is pointing inwards, it doesn't mean कि body अंदर चली गई. It means what? अपने right hand thumb को अंदर की तरफ रखो. ये रहा. Thumb अंदर. Curl. What type of curl you see? Clockwise. Body कैसे rotate कर रही है? Clock. किसने बोला that torque is pointing out. Thumb बाहर. बाहर का मतलब ये नहीं कि body बाहर आ गई. What is this thumb giving you? It tells you that hold your thumb like this, curl. So the point is, the sense of torque, if somebody says use right hand, then is this. But the person who is using left hand for same rotation, he finds that torque is in. तो हमने यहाँ पर क्या बोलना शुरू किया? हमने यहाँ बोलना शुरू किया कि भाई एक काम करते हैं, एक पर्टिकुलर बेंचमार्क क्रिएट कर देते हैं, एक यूनिवर्सलिटी प्रोड्यूस कर देते हैं. एवरीबडी विल से दैट डायरेक्शन ऑफ टॉर्क विल बी डिसाइडेड बाय व्हाट? राइट हैंड. अगर मैं टॉर्क को वेक्टर फॉर्म नहीं देता, मैं केवल क्या बोलता? एंटी क्लॉकवाइज, मेरा काम तब भी चल जाता. What is the difference between this and normal vectors जो आप देखते हो? मैंने बोला velocity इस तरफ है मेरी, and I hope मैंने इसी तरह का एग्जांपल दिया था जब मैं एक्सप्लेन कर रहा था इस आर्टिफिशियल वेक्टर के कॉन्सेप्ट को. If I am moving this way, चाहे आप लेफ्ट ही हो चाहे राइट ही, everybody is going to say that I am moving in this direction. But for torque, using different hands will produce dot or cross. तो हमने इसको क्या बोलना शुरू किया? हमने बोलना शुरू किया कि भाई तुमको एक्सियल वेक्टर बोल देते हैं, and your direction will be decided by what? Right hand. खत्म. And therefore it is an artificial vector, but just don't worry about this artificial vector anymore. For you, in your schools, in your competitive examination, it is a vector. कभी कभी ज्यादा डीप में कराने में भी प्रॉब्लम हो जाती है चीज. होपफुली समझ में आ गया होगा. The question I was asking, good. The question I was asking, where have you seen this unit before? Newton into meter. The Newton into meter was what? Joules, work, force into displacement. So now tell me, can I use unit of torque as joules? Yes or no? Can I say that unit of torque is joules? Yes or no? And the answer is no, we cannot. We do not. It's not about can, it's about we do not. Why? Again, we have a convention. What is joule? Scalar quantity. Work, energy. What are these? Scalar quantities. So joules, which is equivalent to what? Newton into meter. But joule in the form of Newton into meter represents what? A scalar quantity. Whereas this Newton into meter is representing torque, which is a vector quantity. So just write down this. This thing can be asked. Unit of torque is Newton into meter. Unit of torque is Newton into meter. Which looks same as unit of work, joules. But we do not use joules for torque, as joules is represented, joules is taken for scalar quantities like work and energy. Whereas Newton into meter in the form of torque represents a vector. So the question will be, do we have same unit for work and torque? Answer is no. Work is scalar, torque is vector. Answer this. Do we have same dimensional formula for work and torque? Write down in the comment box. Do we have same dimensional formula for work and torque? Good. Now your answer is what? Yes. Dimensionally, if you go, you will get same thing. Unit wise, they are not. So write down this point also. But dimensionally, they both are same. But dimensionally, they both are same. Now, around 1 month back, I had sent you a lecture on dot product and cross product. So if everybody, if you have seen the lecture on cross product, then write down yes in the comment box, and if you have not seen, then write down no. You must provide your response. Have you seen the cross product part of that lecture, yes or no? Because if you have not, then I'll give you a brief idea, and if everybody has seen, then we can easily handle the next part of the torque analysis. Good. So everybody is saying yes, which is a good thing. That saves a lot of time. Look, this is vector A, this is vector B. Angle between A and B is theta. If you have a vector C, which is the cross product of A and B, then C, there is no arrow, this is the magnitude part. C is AB sine theta. Magnitude of first vector, magnitude of second vector, sine of angle between both vectors. And whenever you go for theta, remember, join them with their tails together. Now who will give me the direction of C vector in this figure? If you know about vector cross product, then what is the direction of C vector? C means what is the direction of A cross B? What is the direction of cross product? कुछ लोगों ने सही आंसर दिया हुआ है. They are saying K cap. K cap means out. Now, just write down the statement, but first look at the direction, the way you decide direction of C. This C vector is first of all perpendicular to A as well as B. ये जो black marker है, ये वेक्टर B के परपेंडिकुलर है, A के लिए नहीं है. अब ये A के लिए है लेकिन B के लिए नहीं है. When you write cross product, product of two vectors, see, that product should be perpendicular to both A and B. How you can make this thing possible? Hold the marker like this. I'm holding the marker perpendicular to the plane of the board. This way, it is perpendicular to A. This is also perpendicular to B. But now there are two options. You can hold the marker C. You can hold C like this or this, out or in. Then which way it is? For that we use what? Right hand rule. Curl right hand fingers from A to B. ये जो एरो दिख रहा है ये कहां से कहां होना चाहिए? ये कर्ल कहां से कहां होना चाहिए? A to B using right hand. Put down this information and then we'll write a statement. तो भाई पूरा कंप्लीट डिटेल के साथ अगर देखना है देन just go and watch that lecture where I discuss dot and cross. यहाँ पर मैंने फास्ट करा दिया है. So direction of cross product is given by right hand rule. If it is A cross B, then curl your right hand fingers from A to B. Had it been B cross A, then for direction part, you will curl your right hand fingers from B to A. करने का तरीका क्या है? Identify the plane of A and B. अपने थंब को उससे 90 पर रखो. Not like this. A और B जिस प्लेन में है उस प्लेन से 90 पर थंब. If it is A to B, A से B की तरफ. Had it been B to A, B to A. For rest, you know what to do. Now, हमारा जो सेटअप था वो क्या था? This was R, this was F, this is the axis, Under this force, you found that body is rotating this way. This was the direction of torque, anti-clock, out, K cap. And then this is R and this is F. So what is this angle? Theta. And what is torque? Torque is coming F into R into sine of theta. आपकी मर्जी, आप इसको ये भी लिख सकते हैं R into F sin theta. यहां कोई इश्यू नहीं है. क्यों नहीं है? बिकॉज magnitude. But the moment you see sin theta, आपके दिमाग में आया ये कि भाई ये तो क्रॉस प्रोडक्ट से रिलेटेड कहानी है. एंड देयरफॉर टॉर्क वेक्टर ये R क्रॉस F या F क्रॉस R, इन दोनों में से कुछ भी होता. If somebody says torque is R cross F, magnitude क्या होगा? R F sin theta. If somebody says F cross R, then magnitude क्या होगा? F R sin theta. Magnitude wise कोई change नहीं है. But you know that torque is a vector. Direction wise, this and this, they will be different. So tell me, which one is correct? First or second? This is R, this is F, this is torque. This is the cross product. बोर्ड पर सारी इंफॉर्मेशन है और आप बता सकते हैं which version is correct, first or second. Answer this. Good. The answer is what? First one. It's not the second one. Why? अगर आपसे बोला गया होता R क्रॉस F फर्स्ट, तो राइट हैंड कहां से कहां कर्ल होता? R to F. Look at this कर्लिंग. ये जो कर्लिंग है ये कहां से कहां जा रही है? R to F. And what about this? ये वाली जो कर्लिंग है ये कहां से चल रही है? F to R. फील कर पा रहे होगे भैया, ये R है, ये R से F था, and this one is F to R. अब मैंने आपसे पूछा कि भाई हमारा रोटेशन किस तरह का है? हमारा रोटेशन किस तरह का है? एंटी. Which one is anti? This one. Which one? R to F. So what is R to F? Then which one represents R to F? R to F. What is this? F to R. And therefore, torque, its vector form is R cross F. Note down everything. Now those of you who did not answer this, are you comfortable with this part, R cross F? Difference between R cross F and F cross R? If you have any confusion, write down no. And if you are comfortable with this, then simply write yes. No response. Maybe because everybody answered correctly. कोई इशू नहीं. I think everybody has answered this thing correctly. 1 1 1 1 1 1 1. Now write down the statement. Torque is cross product of R vector and F vector. Torque is cross product of R vector and F vector for the direction of torque. For the direction of torque, curl right hand fingers from R to F, then thumb points in the direction of torque vector. But remember one thing, जब भी आप कर्लिंग करोगे पहले दोनों वेक्टर्स को टेल से ज्वाइन करोगे. यहां कंफ्यूजन होगा. यहां पर ये डायरेक्शन आपको सिंपल लॉजिक से मालूम पड़ रही है कि फोर्स इधर लगा है, इसलिए बॉडी रोटेट कर रही है. Now let's take some examples. Look at this example. This is a point mass. और ये हमारी एक्सिस है. This is a massless rigid rod. क्या मतलब है? This thing has no mass. मास केवल कहां पर है? यहां पर एज अ पॉइंट. ये सब बोलने का क्या मतलब है? मासलेस रिजिड रॉड. हमारे पास एक मासलेस रोप भी होती थी, लेकिन अगर रोप को आप रिलीज करोगे देन इट विल सिंपली कोलैप्स. If you have a rod, then it remains what? Rigid. So this point mass is of 2 kg and the rod makes an angle of 60 degrees with the horizontal like this. अब इस मार्कर में पूरा का पूरा मास है, बट इमेजिन व्हाट कि मास केवल कहां पर है? इस एंड पर, एंड द होल रिमेनिंग पोर्शन इज व्हाट? मासलेस. इफ यू रिलीज दिस थिंग अंडर ग्रेविटी, यू नो दैट इट्स गोइंग टू कम डाउन. This release it comes down. The question is, what is torque acting on the point mass coming from the gravity? Answer this part. Should not take more than 30 seconds. And I forgot to give you the length, sorry. Take the length as 10 meters. Take the length of the rod as 10 meters. देखना भाई इधर, ज्यादातर लोग क्या करते हैं, F is what mg. So first thing many of you will do is this, टॉर्क कितना, फोर्स कितना है भाई mg, r कितना दे रखा है 10, साइन थीटा उठाकर 60, so m is what 2, take g also as 10 into 10 sin 60 root 3 by 2. कई लोग इसके पास जाएंगे बट दिस इज रॉन्ग, क्या गड़बड़ हो गई यहां पर, उसको देखना। When you use theta as sin theta, what is theta? दोनों वेक्टर्स के बीच का एंगल। Now who will tell me the value of theta? I'll just take 1 minute, one more minute. Who can tell me the value of theta in this? देखना, this is R, position R, this is F, is this theta? No. थीटा फाइंड करने का तरीका क्या है, टेल से ज्वाइन करना, दिस इज आर, दिस इज एफ, आर एफ, लेकिन थीटा फाइंड करने का तरीका क्या है, आर एंड एफ, join them with their tails, so this is theta, and you know what this angle is? लोग थीटा की वैल्यू क्या पुट करते हैं, 60, गलत, कुछ लोग 30, दैट इज ऑल्सो नॉट करेक्ट। थीटा इन दिस फिगर इज, देख लेना यार, 150 आ रहा है, दिस इज 30, दिस इज 60, you can produce it like this, होपफुली दिख रहा होगा, ये जो एंगल है तुम्हारा, व्हाट इज दिस, 180 माइनस 30 विच इज 150, तो करेक्ट वर्जन फॉर टॉर्क इज दिस, m g r, sorry, m is what, 2, m is 2 kg, two into G into R multiplied by sine of 150. This is the correct part. Now, ये हर आदमी को पता होना चाहिए, sine 150 is sine of 180 minus 30, which is sine 30. And everybody knows what sine 30 is. This is coming 200 multiplied by sine 150, which is sine 30, which is 1 by 2. So the answer is what? 100. ये है टॉर्क फाइंड करने का तरीका, लेकिन बड़ा गंदा तरीका है, थीटा एंड ऑल को परेशान करना पड़ा, मैं परेशान होना पड़ा। उसकी जगह क्या करना चाहिए था, 1 minute more, उसकी जगह क्या करना चाहिए था, अब जरा वहां चलते हैं। हमने टॉर्क के लिए स्टेटमेंट नोट किया था, टॉर्क का स्टेटमेंट था फोर्स मल्टीप्लाइड बाय परपेंडिकुलर डिस्टेंस ऑफ फोर्स फ्रॉम द एक्सिस ऑफ रोटेशन। टेक अ स्क्रीनशॉट ऑफ दिस थिंग फास्ट। टॉर्क का हमारा तरीका था फोर्स मल्टीप्लाइड बाय परपेंडिकुलर डिस्टेंस ऑफ फोर्स फ्रॉम द एक्सिस ऑफ रोटेशन। उसके पास चलते हैं। अगर उसके पास जाते तो अपने को ये सब नाटक करने की जरूरत नहीं पड़ती। ये क्या फाइंड किया अपन लोगों ने, टॉर्क। लुक एट दिस सेटअप, व्हाट इज दिस, फोर्स। And where is the axis of rotation? This. दिख रहा होगा. Axis force. So what is the perpendicular distance? Between this and this, this is the perpendicular distance. Which is the perpendicular distance? This part. यहां से यहां तक. ये 150 एंड ऑल नोट हो गया होगा. मैं इसको हटा दे रहा हूं. तो अगर किसी ने हमसे परपेंडिकुलर डिस्टेंस पूछा होता तो हम बोलते भाई इतना है बिटवीन दिस एंड दिस. और ये फाइंड करना बच्चों का खेल है. यहां से यहां तक की लेंथ कितनी है भाई? 10. तो ये हिस्सा कितना होगा? 10 का बेस कंपोनेंट. व्हाट इज दैट? 60. 10 बेस. व्हाट इज cos 60? बच्चे को पता है क्या होता है? 1/2 which is coming 5. What is torque? Force. M G. Force multiplied by perpendicular distance of line of force from the axis of rotation, which is coming what? 5. 2500. Same answer. If you understand the second part, then write down yes in the comment box and then you can leave. Thank you very much.